Hi, welcome back. So we're at the outline to discuss transposing and reshaping of matrix. This is a one-dimensional NumPy array. If we want to reshape this, first of all, we have to consider the number of elements, whether they can really shape a square matrix or not. So if we get the length of A, 18 is not going to be a multiple of two numbers. However, if I want to, for example, get rid one of these values here, the length again is 12. Maybe now I'm able to reshape this just by calling the reshape function, and then I decide on the dimensionality that I would like to. Maybe 2 by 6, I will get back two-dimension NumPy array by 2 by 6 to transpose this matrix. It means the rows become columns and columns become rows. So as simple as calling transpose, you will get the rows become columns and the columns become rows. If you call the t as you see here, but this one, the t is considered to be as a class variable. Now next, maybe we can also discuss about reversing an array. As simple as just calling something called the np.flip function. We will get the result as expected by flipping the matrix backwards. And the same thing can be done also with a two-dimension arrays. So this is the original matrix, and basically if we look at the flipping point upside down, so the first element become the last element and go backward. The same thing you can actually flip reversing only the rows, and then I decide on the axis is equal to 0. We see here the result is flipped by rows. If I would do on 1, it means the column is going to be flipped and the result as expected. Maybe you can also look at something called a reshaping and flattening multidimensional array. We worked on converting one dimension to two. Now we are doing the reversing task. So just by getting this dot flatten function and we ran this, the result as expected, all the value have been flattened. Besides flattening, actually you can use another method which we call it the ravel, just like so. And let's just print this one. You get the exact same result. However, what is the difference between using ravel or flatten? So I expect this value to be 0.07. Now, when I did the flatten and I changed amending the second index, watch carefully now when I print it, what happened? The first one is not affected. So the parent matrix is not affected by the amendment that I have done. However, if I do this using the ravel and I make the print, you would see whatever I have done on the reversed one had affected the parent. These are the actual difference between both ravel and flatten. So flatten does not affect the parent, whatever I do in it. However, the ravel, it does affect the matrix. Next, maybe we're going to work on a much more interesting topic, and that is to discuss mathematical formulas on NumPy arrays. See you then.